Paul, welcome on this new video. Today I will show you how you can use BERTopic to perform advanced topic modeling. BERTopic is a framework that creates easily interpretable topics. So to walk you through my Google Colab, I will show you first of all how you can install BERTopic. The installation step is very straightforward. You can use pip install BERTopic. So after you install, make sure to restart your notebook to make sure all the modifications are taken into consideration by the kernel. Then when you finish installing, you can also access the data. So the data I'll be using is the one you can also access it from my GitHub, and here is the link to access the data. And if you want, what I did here is to take this subset of the data to make sure the training process doesn't take too much time. But if you want to use the original data, you can access it from Kaggle. Here is a Kaggle link. And as you can see, the dataset has two main columns, the published date and headline text. Since this project is about performing topic modeling, we'll be using the headline text column in order to perform this task. So what I wanted to do is for some visualizations I performed, I created a new column in order to contain the length of each headline text. So this is the lambda syntax that can be used to perform this task. And as you can see, we have a distribution of the length of these headlines. And the maximum, like the headline, the maximum length is 13 words. And then let's have a look at some headlines. I randomly took some headline text in order to print those. As you can see, this one, and this one. And after that, we can finally come to the topic modeling aspect once we have already the information about the data. So for the topic modeling part, there is the first step. The first one is about training the model, the topic model. And to do so, we'll need different parameters. The first one, this one is optional. I only put these variables so that it doesn't show too much information when performing the training. And the embedding model here, I chose the paraphrase mini LM L3 V2. So the goal of using this one is that because in the framework documentation there are different embedding models that you can use, but this one is the one that has the great trade-off of performance and speed, because when you are training there is the speed taken into consideration and there is also the performance of the embedding model. And there is also a last parameter called minimum topic size. So this minimum topic size, I set this to 50, but the default value is 10. And what you have to understand about this value is that the higher the value, the lower the number of clusters / topic is. So once we initiate the model, then we can perform the training, and this training is used of calling the fit transform, and we call this transform on the headlines column, since it's the one that is what we need to perform the training aspect. So after the model is trained, what we can perform now is to extract the topic representation. So for the topic representation, we can get the topic frequency on using the get topic information. So when we use the get topic information, we have a data frame with three main columns. We have a topic column that is the number, the topic number. Like we have number, like here we have the topic number. It's a kind of the identity or the identifier of each topic. And also the topics labeled with -1 are those that are outliers. Those topic do not have to be taken into consideration when we make the analysis. So we have to ignore them when we perform our analysis. And the count column is the number of words in the topic, in a given topic. For instance, when we take the topic with identifier number 0, we can see that it has 1163 words. And the last column is the name column. Like this is, as the column suggests, is the name given by the topic. So what we can perform now is to maybe try to look at the first topic here. What we see is the topic number 1, and this topic number 1 here is this one. I mean, this is the row number. When I took the ilog, it corresponds to the row number, but it's exactly the topic 0. Here is the topic 0. And from topic 0, what we can get here is calling the getTopic function. This function retrieves, it shows the words and its TF-IDF score. The higher this value is, the better the word is representing the topic. So in this topic 0 here, Cup Win Test England, we can see the main words here, Cup Win Test England, and all along today. And when we analyze this topic, we can see that it's completely understandable. It's mainly about football. Some of you might call it soccer. Okay, so that's what we can see from here. So after we get our topic, what we can do also is to have the visualization. Maybe some of you who used let's say, anyways, let's have a look at this one first before moving to further visualization. So the first visualization we'll use here is the topic terms. Okay, this will be the equivalent of what I showed here. So instead of showing only the words and the TF-IDF, now we can show the graphic representation of those of the previous one. So the topic terms here, we have a topic 0, the one I showed here, the topic 0 here. So for topic 0, we have Cup Win Test England words and so on. And the horizontal bar is the TF-IDF representation. So what I decided to show here is the top 6 topics. I could put 7, whatever number I want here, but I just decided to show the 6 top topics from topic 0 to topic 5. So that's the first representation. And the second representation is the InterTopic Distance map. For those of you who used LDA, latent delay allocation topic modeling technique, this visualization is similar to the LDA visualization. And also I wrote an article about this, and you can click here to access that article in order to know more about the LDA representation. So from here, this graphic, what we can see here is, like, for each topic we have the representation here. For instance, this one is the topic number 1. For the topic number 1, we have the words, the most important words in that topic: man, charged, murder, jail, overs, and so on and so on. And let's say that we want to focus on a specific topic. Here we can choose, let's say, topic number 1. When we go through a specific topic, it becomes red. Here, for instance, we are using topic number 1, and here topic number 1 is highlighted in red. And what we can also do is maybe have a look at those topics here. You can choose one here, and then we can have a better visualization on those topics. We have here topic number 1 with the specific word. Here is a topic 19, court judges, case, appeal, corruption. And what the name InterTopic Distance means is that we can see similar topics that are grouped together. Here, for instance, I had a focus on those topics. Let's look at topic number one. Topic number one is man charged murder jail. But what is also interesting is when we look at topic 19, we have words like court, judge, case, appeal, corruption. And you can see that those two topics are very similar when we look at the words. So that's the most very interesting when it comes to analyzing topics. So when we have such information, we might want maybe to group topics that are very similar. In our case here, for instance, topic 1 and topic 19 are similar, and all along, we can see also topic 17. Topic 17 is police, props, stolen, cop, arrest. And those topics, when we honestly look at the words, we can see that they are very, very similar. And the words that are shown are very similar from one topic to another one. Okay. So what we might want to do is to group topics together, and a technique that we can use is a hierarchical clustering. So what the hierarchical clustering can show and can do for us is to show the similar topic together. For instance, using the hierarchical topic, I would say that I want to show to cluster the top 30, 30 topics or clusters corresponding to the analysis I performed previously. And what I showed from the InterTopic Distance map, I can have the same results on this clustering part. When I showed the topic 1 and topic 19 and topic 17 were very similar, like man, charge, murder, court, judge, case, police, prop, stalling. And those topics are grouped together. For instance, when we have a look at topic 1 and topic 19, those first topics have been grouped together by the hierarchical clustering, and this topic modeling, topic clustering technique is very powerful. And we might want, after using this one, to reduce the number of topic we want. We can cut, let's say here, and when cutting here, what we can have is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then we go from 13 topic to 12 topics. And let's say that we want to cut here. So if we cut here, the intersection with the horizontal bar gives the number of topic we want. So if you want the less cluster we want, we will move from left to right when we want to cut here. So that's definitely what we can use in terms of topic reduction. Also, what is possible with BERTopic is the possibility to search for a given topic. Let's say we want to get the top 3 topics that are very similar to the topic about politics. Okay, so I can use the model I train, find topics, giving the topic search, like the keyword here, which is politics. And also I want to get the top 3 similar topics. So what I get here is 2 values. We have a similar topic variable and the similarity variable. So the similar topics contain the topics index, from the most similar to the least similar. And here the similarity is the similarity scores in descending order. Okay, so I performed my analysis here. So let's say that I want to take the most similar topic. Like I said, this is in descending order. Okay, so if I want to take the most similar, I will take the one at the first level, which is the index 0. So when I take the index 0, the most similar topic is this one, the topic where I get the keywords election, Trump, party, Donald, Obama, liberal, Bush, liberals, votes. Okay, so when we look at these words, we can definitely see that this is about election. and the similarity score is 0.7, which corresponds to 70% of similarity. Okay, so these are quite a things that we can do with topic modeling. So let's say you built this model and you are very satisfied with the result. What you might want to do is to save this model and serialize this model and be able to use it later. This is also possible. So what I did here is to create a folder called a model directory, so called model dir, and I use the .save function to save my model. So I say model.save and I put the path, which is here, and also the name I want to give to the model, and in this case the name is my best model. Okay, so I already saved the model. To make sure that the model has been saved successfully, what I do is to use the load function. Okay, so I say BERTopic.load. I use the exact same path I use here for saving my model. So I use that same path here, BERTopic.load, and here is my best model. So that's all. If you want also to have much more understanding about BERTopic, here are additional resources that you can use, and you also have the link to this um, file like in the description. So feel free to share it, and also I will appreciate to have your feedback about it. Thank you so much and take care. Bye bye.